Hello everyone, my name is Jafari and I would like to welcome you to another video. In this video, we are going to continue learning about data transformation. Specifically, we are going to talk about smoothing, aggregation, and binning. We will first talk about what these three techniques have in common, that we are covering them in one video, and then we are going to see what they are in a few examples. All right. Let's get started. All right, so let's answer this question. What do all these three methods, naming, smoothing, aggregation, and binning, have in common? And the answer is these three techniques might be the right approach to be dealing with noise, random errors. We did talk about what is noise and random errors when we were talking about data cleaning, specifically data cleaning level 3, but let's just have a quick recap. And before that, I want to answer one other question. I believe I've already answered that, but let's answer that one more time. Why does only time series data have noise? If you have ever seen the phenomena of random error or noise, we only see them in the data that it's time series, and noise only are in time series. The answer is, it's not that only time series data have noise, it's that, with time series data, we can actually detect noise, right? So in time series data, we do see that pattern with our eyes. At the same time, we do see that those inconsistency or out of precision of that pattern. And we come to realize those are noise, those are random errors. So again, it's not that other types of data does not have noise, it's that there is no way for us to actually calculate or capture noise. So it is just because of that we only can handle or deal with noise, because we can detect them, and in time series data we can detect them, and therefore we can deal with them. So what is an error? Error, as we discussed, is the difference between the reality and the signal, right? I mean, the reality and the measurement, right? We measure something of a true signal, right? And there is bound to be an error, because our measurement systems are never capable of, actually capturing the true signal or the reality. And that difference is called error. And we did talk about how we have two types of error. We've got random noise or random error or noise, which is basically is coming from unknown incapabilities. I mean, there are incapabilities that we have not come around to be able to address them. And then we've got systematic errors. These are errors that we could have prevented with the technology and knowledge and capabilities we already have. So those are systematic errors. And with the systematic errors, we could actually address them. So that's better to do that when we are dealing with systematic errors. We better go back and address them and have better data collection. With random noise, they're not avoidable. And because of that, we have to deal with them if we can detect them. So we are going to cover three techniques here. We're going to cover smoothing, aggregation, and binning, which is basically the title of this video. Under smoothing, we're going to have two types of smoothing. We've got functional data smoothing and rolling data smoothing. We're going to see what they are and see a few examples, right? So let's start with functional data smoothing. With functional data smoothing, basically, you find a function that can simulate the pattern in your time series, right? For instance, we have this sinusoidal function that is capable of simulating the patterns that are shown in this time series data. And now you can see while this pattern actually captures the pattern, why this function actually captures the pattern, you can, instead of using the actual data, now you can use the function, right? I'm not talking about the parameters of the function. We can actually use the result or the output of the function, and now your data becomes smoother, right? That's why it's called smoothing, and it's called functional data analysis for smoothing, because we're using a function, right? How about rolling data smoothing? While for functional data smoothing we use a function, with rolling data smoothing, what we do, we use the data itself to go about smoothing. And the way we do that, we do something called Windows rolling calculation. So first we consider the first, for instance, if our window length is 5, right? Our window is 5. We capture the first 5 data, and then we do the average of them, and then that would become our first data object, or the first value. And then we shift 1 forward, so we start from 1 to 6, and we do the average again, and so on and so forth. When we do that, naturally our data becomes smoother, because we are using an aggregated value for those calculations. So when you do that, you can actually see, for instance, you've got those ups and downs. You have these random noise or random errors, right? And then once you do the moving average smooth, or the rolling calculation, which is basically the moving average, now you will see a smoother data. There is one issue with rolling smoothing data, is that it shifts your data by the width of the window. It's been shift the data by 5 here, right? You can naively think you can just like shift the data back for 4 or 5 or 6, so these would line up perfectly, but that's not gonna happen, right? I mean, let's look at the actual numbers. So this is the first data object, right? So it used these 5, right? It's the summation of these 5, so you come to this one, and so on and so forth, right? But let's try to match them up. Like what is 186 matched to? If we wanted to move that, you can see there is no match for these numbers to the other one. So there is no easy shifting, so they line up. So that's one of the disadvantages of rolling calculations, rolling data smoothing. All right, so let's now talk about aggregation. Aggregation, is very similar actually to rolling data smoothing. But what is the difference when we talk about aggregation is that with aggregation, we actually shift from one data object to a definition of data object from one to another. For instance, we can say, in this case, we have the daily COVID cases in the US and in California, right? And then we aggregate the data, or like change the aggregation of the data from the daily to weekly, right? So as long as we have that possible definition of data object change from daily to weekly, now for coming from daily to weekly, we have to do aggregation for 7 data objects, right? Because of that, we call this aggregation, and we have to change the definition of the data object. So that's called aggregation. You can see when you do aggregation, for instance, in this case of COVID cases and death in the US and California, you will see that you can actually smooth the data to some extent. And you also see that when the population is larger, there is much more noise, right? You can see those as well in these in this example. All right, so lastly, we're going to talk about binning. Binning is actually the same method as discretization. Do you remember we talked about discretization? We were talking about being able to go back and forth from categories to numbers, from numbers to categories. So we use discretization when we need categories, or when we want categories to be representing our numbers for some reason, right? So that's discretization. But when we use discretization, or whatever it is that we use to address noise, that's when we call it binning, right? So this is actually what exactly we did for discretization, right? So this is the function we use, right? pd.cut, right? With binning, it's the same thing, like I said, but we use it for the purpose of dealing with noise, right? So for instance, we've got the adult DF age, and if we were to create the bar chart of this data, right? This is the bar chart of this data. You do see that you have ups and downs. There's some noise looking data, and then you can use the same function, but the bin of 10, now it will create sort of like a histogram looking data, and now you have dealt with the noise, right? You don't have those ups and downs anymore. And this is exactly the same as creating a histogram, right? So histogram is basically automatically does binning for you, and this is the same as exactly this one, right? So we are not creating a histogram, we are using a bar chart, but before that we have binned the data, but histogram does that automatically for us. And binning or histogram are ways you can sort of deal with noise. All right, until the next video.